triangles are your best friend in geometry. There's so many things you can do with right triangles to help you solve problems. We've already learned similar right triangles. Like if you draw an altitude, you create three similar right triangles, and you can use geometric mean to find pieces that you're missing. We're also going to talk today about Pythagorean theorem. Okay, and this, so you've studied Pythagorean theorem before. A squared plus b squared equals c squared. The thing you need to remember is that a and b are the legs, the two pieces that come together to make the right angle, and c is the hypotenuse. Okay? You can always tell the hypotenuse because if you put your pencil in the right angle and just draw a line straight out, it will always intersect the hypotenuse. It's always across, whether it's upside down, sideways, whatever. If you put your pencil in that corner, draw a line straight out, it will always cross the hypotenuse. All right? So our goal today, our targets are to remember the Pythagorean theorem, but also to use it in real world problems. So I like to do this because this was actually real world for me. This is the front steps of my house. They're 20 inches tall, and my mom is in a wheelchair. So we were building a ramp so that she could get up to my front door, so someone could push her up there. And the problem was there's a tree like at the end of my yard here that was kind of blocking, that could have blocked it, and there's a limit to the degrees, there's a legal limit to the degree a ramp can be, because if you think about it, like if you built a ramp like this, you know, if you accidentally let go or tripped, oh my gosh, you'd be hurtling backwards. So there's a law about what the degrees are for the end of the ramp. So I knew that the ramp was going to be 15 feet, and I needed to check to see if I had enough room before I hit that tree. Okay? So I used Pythagorean theorem. Okay? I knew this was 15 feet. I knew this was 20 inches, and I just needed to see how many feet that was. All right? So what would I have to do first here? Yeah, you have to convert the 15 into inches. So 15 times 12 would be what, 180? Okay, oops, not 180 degrees, just 180 inches. Okay, so then I use Pythagorean theorem. What are the two legs? Right, 20 and x. The two sides that come together to form the right angle. So it's 20 squared plus x squared equals 180 squared. All right, so 400 plus x squared equals, I think, 32.4. Is that right? Somebody check, but I think that's it. And then I'm going to subtract 400, and I get x squared is equal to 32,000. And then take the square root, right? Because to undo squaring, you take the square root. So I'm going to take the square root of both sides. And that gives me x is equal to 14.8, I believe. Is that right? No, that's not right. That's in feet. Say again? 178.85. Okay? And then that's in inches. So to figure out how many feet that is, I divide by 12. And that, I think, comes out to be 14.8 or 14.9. So maybe 9? Okay. So is it going to fit my 15 feet I have before my tree? Barely, but yes. Yes. Yeah, you can, yeah, you can leave it in decimal. All right? So that's like a real world example of using Pythagorean theorem. And hopefully that's, I'm sorry? No, inches, 20 inches. Yeah. All right. So you know that the Pythagorean theorem says if it's a right triangle, then a squared plus b squared equals c squared. So the converse would be if a squared plus b squared equals c squared, then it's a right angle, right? Converse just changes the order. So the way you tell if you have a right triangle, and like this is the kind of thing that architects would use to make sure they've got a right angle. You can, if you plug these numbers into the Pythagorean theorem and it works, then you know you have a right triangle. So if I wanted to check to see if this is a right triangle, I would do 4 squared plus 6 squared equals the square root of 52 squared. So 4 squared is 16, 6 squared is 36, the square root of 52 squared is 52, and 16 plus 36 is 52, right? So this is a right triangle. Okay, check and see if this one is a right triangle. Now, there's something else that's kind of cool about Pythagorean theorem, and that is it can identify acute and obtuse triangles as well. So we know that if a squared plus b squared equals c squared, it's what kind of triangle? Right. Okay? If a squared plus b squared is greater than c squared, then it's acute. And if a squared plus b squared is less than c squared, the triangle is obtuse. Okay? The less than and greater than kind of seem counterintuitive, but think about that for a second. If a squared plus b squared is greater than c squared, that means c squared, or c, is probably short, right? So to make the triangle, the c, the bottom here, is going to be short. So look at the angle at the top. What kind of angle is it? Acute, right? So if a squared plus b squared is more than c squared, that's going to make that acute angle at the top. But if a squared plus b squared is less than c squared, that means c squared must be pretty long, right? So to accomplish that long, to hit that long side, see how the angle opens up and becomes obtuse? Does that make sense? So even though it's kind of counterintuitive, that's why it's greater than is acute, less than is obtuse. All right? And the other characteristic of a triangle, and you'll have to write this down if you copied the notes off the website. Okay, to prove or to show that something's a triangle, the sum of two sides of a triangle has to be greater than the third side. Okay, lines and writing. It has to be greater than the third side. Oh, won't turn off either. There we go. Okay, which means, like, example. So the sum of two of the sides, any two sides, has to be greater than the third side. So to check to see if this is even a triangle, what we would do is we'd add these two. So 11 plus 8 is 19. Is 19 greater than 13? Yeah, so that works. Then 13 plus 11 is 24. Is that greater than 8? So that works. And then 8 plus 13 is 21, and that's greater than 11, so that works. So any two sides is greater, the sum of the any two sides is greater than the third side. So this is a triangle. Okay? I'm sorry? Yeah. Yeah. So you would, if you have, like, let's say I have the bottom of my triangle is 12 inches. Okay? If I have a 5-inch and a 5-inch side, are those two sides, the sum of those two sides greater than this? No. So when this falls in, are they even going to touch? No, so they're not going to make a triangle. They're just going to make a line, right? But if this one, made, let's say, is 9 inches, we've got 9 plus 5, which is 14. Isn't that greater than 12? So when these fall in, they're going to cross, and they're going to hit each other and make a triangle. Do you see why the 2's has to be greater than the third? Okay? So any 2, let's see what kind of triangle it is. Which one would be the hypotenuse? 13. So I do 8 squared plus 11 squared, and then I don't know if it's going to be equal to, greater than, or less than 13 squared. So 64 plus 121 and 169. 64 plus 121 is 185. 185 is greater than 169. So is it acute, obtuse, or a right? Acute, right? If it's greater than, it's acute. Okay? Take a minute and see if B and C, first of all, determine if they're triangles. If it's not a triangle, can it be in a right triangle? No, if it's not a triangle, you're done. It's not a triangle. And then, but if it is a triangle, find out if it's acute, obtuse, or right. So 202 is less than 225. So what kind of triangle is it? Obtuse. Good. Yes. Because if you add 5.8 and 9.3, no, not squared, just straight up. To determine if it's a triangle, you don't have to square them. You're just adding them together. To see what kind of triangle it is, that's when you square them. So any 2 sides have to add up to be bigger than the third side. So like this one only adds up to be 15.1, which is less than 15.6, okay? But yeah, just straight. Does everybody get that? Because that is a problem people have. When you're trying to figure out if it is a triangle, it's just straight addition. You don't square anything. You don't do anything like that. Just straight addition, okay? All right, and the last thing we have here, and these are just like kind of like cheat codes, all right? There are certain side lengths that always make right triangles, and we call those Pythagorean triples, okay? And the 4 smallest ones, there are more, but they get pretty big, and it's not worth memorizing, not worth taking up the brain space. But these 4 are they're small and they're easy to memorize. So these sets of numbers always make right triangles. Okay, so if you see a triangle and it's labeled 3, 4, 5, it is definitely always a right triangle. Or if it's labeled 5, 12, 13, always a right triangle. 8, 15, 17, 7, 24, 25. So like I said, there's more, but they're kind of big and bulky and hard to memorize. But if you memorize these 4, you'll be good. All right. Not only do these work, but also they're multiples. So 2, 4, 5 could also be 6, 8, 10, or 9, 12, 15. Okay, like all their multiples also are Pythagorean triples. Okay, does that make sense? Yeah. Right. Exactly. That's just a Pythagorean triple shortcut. Okay? All right? So I have this game called Vortex. And if you grab, like, here's 3, 4, 5. Is that a right triangle? Yes. So if I grab it and pull it over into not a right triangle, it's going to spit it back out. And if I grab it and put it in the right triangle, it's going to swallow it up. Okay? So as soon as you have one, you can come up on the board and move it. So the